everybody, I hope you guys are having a wonderful day. In this video, we're going to start learning about the basics of probability. So take 3 deep breaths and let's make this math easy. All right, so when we're calculating probability, we're looking for the chances that something will happen. And the way that we calculate probability is we say that the probability, which we're going to represent with the letter P, of whatever your desired outcome is, equals the number of desired outcomes divided by the number of possible outcomes. So for example, if you were going to roll a 6-sided dice, you have 6 possible outcomes. You could get a 1, a 2, a 3, a 4, a 5, or a 6 whenever you roll a 6-sided dice. So if you were looking to find the probability of rolling an even number, the way you would calculate this is you would say, well, there's 6 possible outcomes, and the number of favorable or desired outcomes is 3 because there are 3 even numbers on a dice. Those even numbers are 2, 4, and 6. And so the probability of rolling an even number would be 3 out of 6. And you can express this probability as a fraction like this. You could reduce the fraction by dividing the top and bottom by 3. Or one of the most common ways to represent probabilities is with a decimal or a percent. So if you do 1 divided by 2, that equals the decimal 0.5. And if you convert that into a percentage by moving the decimal over twice, this tells you that the probability of rolling an even number is 50%. So let's do another example. Let's say that a group of people were asked if they knew of Tide laundry soap. And when they were asked, 67 of them did know of the Tide laundry soap and 23 of them did not. If we wanted to find the probability that a randomly selected person will know about Tide laundry soap, the way that we'll calculate this is we'll say, okay, well, the probability of our desired outcome, which is knowing about Tide laundry soap. In order to calculate this, we need to first decide how many possible outcomes there were. So the total number of people that were asked this question is 67 plus 23. And so there's a total of 90 people who were asked if they knew about Tide laundry soap. So that's the total number of possible outcomes. And then the number of favorable or desired outcomes, or those people who know about Tide, would be 67. And so I could leave this as a fraction, or I could do 67 divided by 90, and that would give me the decimal 0.7444444, etc., which means that this is approximately 74% likely that a random person would know about Tide laundry soap. Let's do another example, this time with playing cards. So if you're not familiar with a standard deck of 52 cards, that's something that you will need during this unit. So you might want to take a screenshot of this slide so that you can remember how the deck of cards is built. Basically, there's 4 different suits. So there's clubs, spades, hearts, and diamonds, and each suit has an ace, and then all the numbers up to 10, and then a jack, queen, and a king. So there's 13 cards in each suit. So if we wanted to figure out the probability of randomly drawing a card from a standard deck of cards and drawing a heart, the way that we would do this is we would say, well, there's 52 cards total that we might choose. So that's the number of possible outcomes. Then the number of desired outcomes is 13 because there are 13 heart cards in a deck. And so when you simplify this, this can be simplified to 1/4. And if you do 1 divided by 4, that will give you the decimal 0.25, which tells you that the probability of drawing a heart would be 25%. So that's another example of how to calculate probability. Now, sometimes you'll have to interpret data from a table or some other type of representation in order to find the probability. So in this example, it says the favorite colors of 28 people are summarized in the table below. If you randomly select a person from this group of people, what is the probability you will select a female whose favorite color is red? So we're looking to find the probability of choosing a female whose favorite color is red. And so first of all, we need to say, well, how many possible outcomes are there? Well, there's 28 people in this group because that's what the problem told me. Or I can also see that I have a total of 28 here. By the way, these totals here mean that there's 11 females total and 17 males total. And these totals represent the total number of people whose favorite colors are green, blue, red, yellow, etc. So anyway, we have 28 people total. And the number of females whose favorite color is red is 3. And so the probability of choosing a female whose favorite color is red is going to be the number of favorable outcomes, which is 3 out of 28. And if I divide 3 by 28, that will give me the decimal 0.10714, etc., which means that the probability of choosing a female whose favorite color is red is about 10%. Or maybe 11% if you rounded it up. So that's how you would pull the information from a summary table like this. And sometimes you may run into problems where you don't actually know the total number of people, but you can still figure out the probability. So for example, in this problem, it says in a certain math class, 30% of the students earned an A, 40% of the students earned a B, 20% of the students earned a C, 8% of the students earned a D, and 2% of the students earned an F. And it says, if you randomly selected a student from the class, what is the probability that you select a student who passed the class? Now, one of the problems here is that we don't know the total number of students. We know the different percentages of students, but we don't know the total amount of students. However, you can still calculate the probability by working with percentage measurements. So you could say, okay, well, I'm looking to find the probability of choosing someone who passed the class, and the total number of people is unknown, but I know that the total percentage of people would be 100%. So I can use 100 as the denominator of my probability. And then I can say, okay, well, what percentage of the people passed the class? Well, obviously these 30% passed the class, and the 40% who got a B also passed, and so did the 20% who got a C. And so if I add all of those together, that tells me there's a total of 90 percentages out of the 100% that passed the class. And you could change this into a decimal if you wanted to, which would give you 0.9, or you could change it into a percentage. And that basically says that the probability that you select a student who passed the class is 90%. So that's the basics of probability. And we'll get into some more advanced examples. But for all probability, what you're really just looking at is you're trying to find the ratio of the desired outcomes compared to the number of possible outcomes. So I hope you guys enjoy your assignment, and I hope you have a good day.